Hello, friends. Good evening, and welcome to my YouTube channel with my name researcher Yugal. So, as you all know, that I do post videos related to different content, sometimes technical and sometimes non-technical. So, let me find out the uh, content for you, and after that, I will share my screen with you all so that you can able to watch the content. So, this is the content is over here. Yeah, I'm sharing this information or the knowledge about the electronics, and the subject that we are discussing is electronic devices and circuit theory, which is from Robert L. Boylston and Louis Naschelski. These are the two authors. So let me share my screen with you all. So let me share the screen. The book is ready now. Share the entire screen. So my screen is visible to you all. So yes. So this is the book that I am discussing, and we have already discussed the two chapter of this book, that is Electronic Devices and Circuit Theory from Robert L. Boylston and Louis Naschelski. So we shall move to the third chapter, that is Bipolar Junction Transistor. So let me make it zoom. It is 153%. So now it is zoom. Hmm. Now let's start our discussion. Friends, bipolar junction transistor. In short form, it is known as BJT, bipolar junction transistors. It is a three-terminal device. It has the emitter, it has base, and it has collector. And it is one of the devices which whose output current is quite high, and it has a higher current gain than the voltage. And if I'm wrong in this particular statement, it will be corrected in the. But as per my understanding, the current gain in BJT is higher, whereas the voltage gain in MOSFET is higher. However, the MOSFET is a low power device, whereas bipolar junction transistor is a speedy device, but it takes a lot of power. That's why the use of bipolar junction transistor got reduced over the period of time. But initially, when the MOSFET was not there, we were discussing the BJT only. And BJT are of two types. One is NPN, another is PNP. NPN is better than PNPN because the mobility of electrons is higher than the mobility of holes. And all those who are the student of electronics or they have the interest in electronics, they know this concept really well. So let's start our discussion. Let me discuss the objective that we will cover in this particular chapter from Robert Oilberg. Uh, we will be familiar about the bipolar junction transistor. We will be able to apply proper biasing to ensure operation in the active region. See, diodes works in two regions. One is forward bias and reverse bias, whereas the BJT works in four regions: active, reverse, cutoff, saturation, and the active and the inverse active or the reverse, cutoff and the saturation. So there are four modes of operation, but the BJT act as an amplifier in the active mode, active region. So we have to, if we have to work with the BJT, and if we want to work it as an amplifier, then we have to make it work in the active region. And we will be able to explain the characteristics of NPN or PNP transistor, that like we will be discussing the NPN or PNP transistor. And we will be able to define the parameters and the response of a transistor, that is a BJT. And we will be also be able to test a transistor and identify the three terminals. I already told you in the beginning of this video. And if you will check the playlist of the discussion electronic devices and circuit theory, this is the ninth video of my discussion, and it is a kind of a lecture or a discussion or a talk in front of you on the topics that we have discussed. So, topic for our today's discussion is BJT. Let me bring out the diary and the pen so that I have the discussion. Pen दे दो ना, pen नीले color. So let's start our discussion on the BJT. We have already started the discussion. The BJT was it was discovered by Dr. William Shockley, Walter H. Brattain, and John Bardeen. Demonstrated the amplifying action of the first transistor at Bell Telephone Laboratory, as shown in the figure 3.1, in the approximately year of 23 December 1947. This was a discussion that was shown by Dr. S. William Shockley, Walter H. Brattain, and John Bardeen, demonstrated the amplifying action of the first transistor at Bell Telephone Laboratory. So, if you think where it was discovered or invented, it was in the Bell Laboratories, Bell Telephone Laboratories. And this is the history about the Dr. Shockley, Dr. Bardeen, Dr. Brattain, and these are the pictures of the three scientists that are working on the amplifying action of the BJT that is known as the transistor. So they were associated with the AT&T Bell Laboratories and Bell Laboratories, and these are the archives you can see in this particular, and all shared the Nobel Prize in 1956 for this contribution. And for this contribution toward the transistor, they were awarded with the Nobel Prize in 1956, and the co-inventors of the first transistor at Bell Laboratories. So these are the figures. One, two, three. These are the three scientists: Dr. William Shockley, Dr. Warden, Dr. Brattain. So this is the history about the transistor. Let's move our discussion from the history to the current perspective. See, the construction of transistor consists of three regions like this. One is like, for example, in this figure, this is P and P. So likewise, there will be NPN also. And I already told you in the beginning of the discussion that there are two types of transistors. One is NPN and another is PNP. If someone asks you a question that which is better, so obvious answer is NPN is better. Why? Because the NPN has the majority charge carriers as the electrons, and the mobility of electron is higher than the mobility of the holes. So here the discussion is over about the which is better and which is not better. So the simple answer is that the NPN is much better than the PNP. And in the construction of the emitter, in the construction of the transistor, we have three regions. One is emitter, it is denoted by E. We have the collector, which is denoted by C. We have the base, which is denoted by B. The area of the base is very small. The area of the emitter is medium, and area of the collector is quite large. Why? Because it needs to collect the large number of electrons that are flowing from emitter to base and to the collectors. So the base area is very small, emitter area is medium, and the collector area is quite large. This you will understand better when we will discuss the working of the bipolar junction transistors. So I think that is it is quite interesting. So, and if you talk about the doping concentration of the emitter and the collector and the base is lightly doped, collector is moderately doped. Medium doping is done towards the collector, and the emitter is heavily doped. So the doping is also different, and the area of the three regions, that is the emitter, base, and collector, is different, and their doping is also different. This point to be noted. I mean, these 2 points to do be noted, that is the doping is different, and the area of the three region EBC, emitter, base, collector, is also different. So the transistor operations, like if suppose there are 100 electrons in the emitter. See, this is P and P, and this is P and P. So here it is shown with the discussion with the PNP transistor. Let me check out whether there is PNP transistor on NPN or not. So, oh yes, it has shown the NPN. So the configuration of NPN is like this, and the configuration of PNP is like this. Only the polarity got reversed in case of NPN and the PNP. But if you need to understand the working of the NPN or the PNP, like suppose this is the P, and this is the N, and this is the P region. So, like if suppose there are 100 holes in the P, then they will move from emitter to base. The 5% of the holes, like for example, five holes get recombined with the electrons, and they form the recombination current, that is the base current. They flow towards the base and get into that. And if we the remaining 95 holes will pass on to the collector, and they will generate the current IC. So here I'm talking about the holes in case of PNP. But if I'm talking about the NPN, there will be flow of 100 electrons from the emitter, 5 will be combined in the base, and the 95 will be collected by the collector, which will give rise to the collector current IC. So there are three types of current that flow into the BJT. One is emitter current IE, base current IB, and the collector current IC. So if we look at the equation is equals to IE is equals to IC plus IB. And here the discussion is the same that I am talking about you. And we apply the Kirchhoff current law to the equation. Then the equation becomes IE is equals to IC plus IB. Whereas the 95% of the current is given by the IC and the 5% of the current is given by the IB. The total current will be equals to the IE, which is the 100% of the current, 95 plus 5. So here, for example, plus minus this P and P. P is connected to plus and N is connected to minus. So it is forward bias. This region of the transistor, PN, is forward bias, whereas the NP is reverse bias. See, P is connected to minus and N is connected to plus. So the input junction or the emitter base junction got forward biased and the base collector junction or the output junction got reverse biased. So there are four possibility of configuration. Like for example, this is forward bias and this is reverse bias. One, this is forward bias, this is forward bias. Two, this is reverse bias and this is forward bias. Three, this is reverse bias and this is reverse bias. Four. So likewise, there are four possibility of configuration for the transistor, and this I already told you in the beginning. And now you can understand with this particular diagram as well. And I think you are able to recall this what I'm trying to say. So this is the symbol of the uh, PNP transistor. Like arrow denotes the direction of the flow of current. The direction of the current is from positive to negative. So this is positive and this is negative. That's why it is flowing from positive to negative. And here, this is the connection or the configuration of the NPN. The N is connected to minus and P is connected to plus. So this is forward biased. And P is connected to minus and N is connected to plus. So this is reverse biased. So likewise, you can understand the working or the configuration of the BJT, and this is the symbol of the NPN. The NPN. This is N. Sorry, this is N. This is P, and this is N. So direction of current is from positive to negative. This is positive. This is N. This is P. This is N. So positive to negative. Positive to negative. And arrow shows this is from positive to negative. So likewise, there are two types of symbols and two types of BJT. We have two types of BJT. So we have two types of symbol. One is NPN and other is the PNP. So I already told you there are four modes of operation. One is active mode, cutoff mode, saturation mode, and the inverse active mode. So you got the four mode of operation. Four mode of operation. Now, how many types of configuration can be possible in the case of the transistor? Like suppose this is base, this is C. The arrow pointer, the arrow side is the emitter. This is E, and this is base. This horizontal side is base, and this is also horizontal side. Horizontal dark color side is base, and this is collector. So if you make the base common, then it is called common base configuration. Here you can see the common base configuration. So if you make the base common, then it is called common base configuration. And if you make the emitter common, then it is called common emitter configuration. The current gain of the common base is alpha. The current gain of common emitter is beta. The current gain of common collector is gamma. And these all we will discuss in these characteristics. So the input current for the common emitter is IE and the output current is IC, and base is common, so the common current is IB. So if we draw the input characteristics are drawn between the input voltage and input current. So the input current, if you see, it is IE. Here it is also seen, it is IE. And the input voltage VBE, which is VBE, base to emitter voltage. So it is denoted by VEE or VBE. And the output voltage is kept constant. So this is the input characteristics of the common base configuration. You can see the voltage is increasing, and as soon as it achieves the threshold voltage or the cut-in voltage, the current got increases. So there are three types of output voltage: VCB1, VCB2, and VCB3. The value of VCB1 is equals to 20 volt. The value of VCB2 is equals to 10 volt, and the value of VCB3 is equals to 1 volt. So you can understand this characteristics is drawn between the uh, input voltage and input current, keeping the output voltage constant. That's why it is called the input characteristics. Likewise, you can understand this output characteristics. This is the output voltage and this is the output current, keeping the input current constant. And what is the input current? It is called IE. And you can resemble this with the previous diagram as well. So here the output voltage and output current and the keeping the input current constant. So you can see these are the various characteristics: IE1, IE2, IE3, IE4, IE5, IE6, IE7. One, two, three, 4, 5, 6, 7, 8. So eight are there. This is 0, 1, 2 milliampere, 3 milliampere, 4 milliampere, 5 milliampere, 6 milliampere, 7 milliampere. This region is called the saturation region. This side. This is called the cutoff region when there is no flow of current, and this is called the active region or the region where you will get the current. This is saturated region. This is cutoff region, and this is the active region. In MOSFET is the characteristics are different that we will study when we will discuss the MOSFET. So likewise, we studied the common base configuration. Likewise, we have the common uh, emitter as well. So let me discuss and the current gain is alpha IC over I, and I already told you what is the value of the alpha. Alpha is almost zero point 0.9 to 0.998. This is the value of the alpha, and this is how we do the biasing. The two battery model is used for the biasing, plus and minus, and this is input current, this is common current, and this is the output current. This thing you can understand because I already told you the discussion. So there is a breakdown region also. So likewise, we have the common ammeter configuration. You can see that this is the diagram for the common ammeter configuration, and what is the current gain for this is the input characteristic of the uh, common gain. And this is the output characteristics of the common ammeter. So, and you can see the current gain is beta. Beta is equals to IC over IB. IC is the output current and IB is the input current. So you can understand these are the two characteristics. This is the output and this is the input characteristics. And this is the common current gain, which is denoted by, common ammeter gain, which is denoted by beta. And beta is equals to IC over IE. And what is the value of beta? Beta is from 50 to 400. So beta is 200 times than it is 50 to 100, sometimes 200 or 400. These are the general values of the typical value of the beta range from 50 to 400. Whereas the value of the alpha is from 0.9 to 0.998. Now let me discuss the common current configuration as well. These are the common current. Sorry. These are different things. They are the explanation of the same characteristics only. And you can see the relation between the beta and the alpha. The relation is beta is equals to alpha upon 1 minus alpha. And you can see in terms of alpha as well, alpha is equals to beta upon 1 plus beta. This is one of the important characteristics that comes in exam to prove. And you can simply prove by this logic. I is equals to IC plus IE, IC over alpha, IC plus IC, you divide by alpha and beta. 1 upon alpha is equal to 1 plus beta. Beta takes common, beta get multiplied, and you get the alpha is equals to beta 1, beta plus 1, and beta is equals to alpha upon 1 minus alpha. You can remember this and you can prove this whenever it is asked. So, and these are the three biasing. Like two battery can be used. Single battery model will also be used. That we will discuss in another discussion. And this is the breakdown region. And yes, I was coming to this point only. The common collector. You can see this is the C. The collector is common, and the emitter is the output, and the base is the input. So here the input current is IB, and the output current is IE, and the common current is IC. And this is how the transistor got connected. This is the NPN connection, and this is the PNP connection. So whenever we are studying the transistor, we will be studying two types. One is PNP types, and another in NPN types. And this is I have already told you in the previous discussion. So these are the symbol in common collector mode, symbol of NPN in common collector mode. and this is how the characteristics look like. See, the input current is IC, input current is IB. This is something different. So let me come to the characteristics. So the characteristics are not shown over here. So you can redraw the characteristics by yourself. The input current will be IE. The output current will be IE. Input current will be IB. Input voltage will be VBV or VBE, or output voltage will be VEC, and output current is equals to IE. So you can clearly come to the discussion that I'm trying to say in front of you all. And there is a transistor specification sheet or the data sheet. Generally, we refer it as a data sheet. Whenever we try to do experiment with any transistor, we try to see the specification of any transistor. Then only we can work with that. Otherwise, if we are not able to read the data sheet, then we cannot proceed further. So this is the one of the symbol of the transistor, that is 2N4123. This is common collector, base, and emitter, and this is manufactured by Fairchild Semiconductor, and this is the trademark of the Fairchild Semiconductor. So you can refer to this particular transistor, which is known as 2N4123. So this is the data sheet. You can read it out, and if you want any configuration, any characteristics, any parameter, then you have to refer this for this particular while referring to this particular transistor from Fairchild Semiconductor. So these are the some characteristic graph. When you search over the internet, over the Google or over the website, you can easily get the data sheet of any transistor that you are working on. There are various types of transistor, two types, NPN and PNP, but in which the manufacturers are different, the companies are different, and the people who are making the transistor are different. So that's why they form the standard data sheet. However, the type of the data sheet will be same, but the characteristics can be different. It varies from transistor to transistor. So beta variation, sometimes you need to vary beta, sometimes you need to vary the IE, IB, IC for output voltage or output current. Likewise, you can do the discussion. So this is the transistor testing. So you can easily, there is a port. This is the port like this, which is used to identify the transistor, which lead is the emitter and which is emitter and which is collector, emitter, base, and collector. You can, there is a this sort of pins are there in the multimeter. Insert the pins in the multimeter. If it is correctly inserted, then it will give a beep sound. Otherwise, it will not give you the beep sign, beep sound. So I think that's it for the today's discussion. And this is the transistor development characteristics. This is goes from 1960 to 2010, and look at the number of transistors used in any chip or any IC. Intel 80286 used 100,000, 10 lakh transistor, 1 million in Intel 804861, and Intel Pentium 4 uses more than 10 crore. 100 million label transistors are used in Titanium 2, Core 2 Duo, or this is, you can see the 100 label, Intel 404, Intel 8004, in RAC 1802, Intel 8005. So you, all those who are the student of electronics can easily relate to this graph, that what this graph is trying to say or not. So I think that's it for the discussion. So this is the summary. You can read the summary, and if you try to recall the video, previous video and the present video, then you can easily understood what are the summaries are available here. But however, you can download this PDF of the book, and if you are following my discussion, then it will be easier for you to relate the discussion and to understand the books, the concepts of the book, quite fundamentally and in a nice manner. So I think that's it for our today's video. We will meet you in the next video. These are the problems that you can do. And yes, now we will study in the next part of our video, we will discuss the DC biasing of the BJT. So here I'm stopping the video, and I hope you like the video. And if you really like the video, give your comments and suggestions. And if you have any question, you can post them in the comments section. I'll be really happy to answer all your questions, and I'll be really happy to accept all your suggestions. Thanks for watching, and have nice time. Thank you.